think I got everything figured out now. The sound wasn't working in the first class, so they didn't get to hear the video clip that we're gonna watch again, right? Yeah. We watched it home today too. Okay. So I want to accomplish 3 things today. Thing number 1 is we got notes to do. Thing number 2 is I've got the homework packet for this unit to hand out to you. And thing number 3 is I've got homeworks and formatives and all that stuff to hand back to you. I do not have the tests or the extra credits graded yet, so I'm waiting on a couple more to get done, so then we can just grade them all at one time. Okay? All right. Happy National Random Acts of Kindness Day. Okay? I learned that one today, again, making my breakfast, and I'm like, oh, that's perfect, because I'm like, I totally forgot to do one yesterday and put it in the notes, so here it is now for today. Random Acts of Kindness. Okay? Some of you were walking out some of you were walking in when the first class was walking out. They were confused because they also sat here like this the whole time. Okay? They didn't interact with this stuff. This stuff on the surface is relatively easy. I am really not teaching you anything brand new today, other than maybe 1 or 2 things. Okay? All of this stuff is logical, stuff that you've done before, etc. Okay? It's just in a different form because today we're talking about vectors. Okay? All right? So allow me to introduce you to vectors.
Hey. I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term, a quantity represented by an arrow with both direction and magnitude. Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh yeah! Check out my new weapon. Piranha gun! Oh yes! Fires live piranhas. Never seen one before? No, you haven't. I invented it. Do you want a demonstration? Oh! Ah! It's so difficult sometimes to get the brain back inside.
Piranha gun! Alright? So, that Despicable Me, when that clip came out, like when that thing got on the internet, it was like, oh, that's how we're going to introduce vectors for the rest of my teaching career. Because it's true, okay? It's true what Vector was saying. We're going to skip this warm-up here today because we're going to get a little extra time in. We'll come back to that later at the end if we have to, okay? Okay? So a vector represents a quantity that has both magnitude, okay, and direction. Okay? That's true. Everything that Vector said in that clip from Despicable Me was true. Okay? The magnitude of a vector is the vector's length. Okay? So magnitude is length. Okay? And it's got a direction. Okay? Because it's going in a specific angle relative to trig. That direction is going to be sometimes in bearing. Okay? When it's in bearing, that means it could be in a degree form, or it could be in that north-south degree form, east-west kind that you learned on Friday. Okay? So it could be in either one of those. What you have to do is, if it's in one of those, you've got to transfer it to a trig direction. Because this direction that we use it in we're going to use it as a trig angle. Okay? So it may come to you in a different form. You're going to have to convert it to the trig angle and then use it as the trig angle. You may also have to use the reference angle for it. Okay? So you might have to do a couple of different things. Then, at the end, when you're giving your answer, then you have to revert back to the form of the angle that the problem gave it to you as. Okay? So if it's a north 32 degrees east angle, okay, that's the angle that was given to you in the problem for your vector, you're going to convert that to a trig angle, 58 degrees. So you're going to use, your angle is going to be 58 degrees. Okay? Then you're going to have to convert that back to whatever, after you get done using it, then you want, like, you might convert to wind might act upon, and it might be, south 18 degrees west would be your answer. Okay? So you got to do all your conversions, use it as a trig angle, and then convert it back for your answer. Okay? So with that being said, now let's jump back to the warm-up. Let's convert this angle so that we get back into thinking about that, because we're going to need to use that. Okay? So draw yourself a bearing of 232. Then give me the trig angle, the reference angle, and the Friday from last Friday angle for it. So a bearing of 232 degrees would start up, come clockwise through here for a bearing of 232 degrees. Okay? So 8 more gets me to 240 degrees. 48 more, or excuse me, 30 more would get me to 270 degrees. So this in here would be a 38 degree angle, which would be my reference angle of 38 degrees. My trig angle would start from the right and come all the way around counterclockwise to my bearing angle. So that would be 180 plus 38. So that would be a 218 degree angle. My angle from Friday, north-south angle east-west form, that's the goofy one. That one comes off of the vertical instead of the horizontal. So I need to find that one there. So that would be a 52 degree angle there. So that would be south because I'm on the bottom half. 52 degrees west because I'm on the left side. Okay. Questions on that?
Okay, say if it's like a northeast, like would it come off of
The vertical.
positive
So
y axis?
if you're saying that if we had here.
Yeah.
Okay. So if that's my angle, and I'll just make up an angle here. So if this is 27 degrees, then it would be north 27 degrees east.
Okay, sounds good.
Yep. And then the other one, the trig angle would be 63 degrees. My reference angle would be 63 degrees, and my bearing angle would be 27 degrees.
Thank you.
Mhm. Okay? All right. So, let's get back into vectors then. Okay? So, in general, a vector is a directed line segment that has a head and a tail. So, literally, on a vector, it's an arrow, yes, okay? But the tail is the start of the vector. That's at where you originate from. Okay? And the head is at the arrow end. Okay? Vectors have a special form. Vectors have what's called component form. Component form of a vector tells you the horizontal distance the vector travels, that's the A value, and the vertical distance that the vector travels, that's the B value. It's not parentheses, okay? Just so you know, it's not parentheses. It's not brackets. It's kind of like the sides of a hexagon over there, okay? So it's kind of like a really large mouth that's being opened, okay? You know what I mean? It's not curved, because if it's curved, if it's a parenthesis, then it's a point, okay? The other thing is we like our vectors to have a little arrow over the top of its name, okay? Because then that signifies that it's not a variable, okay? That tells you that we're talking about a vector v and not variable v, okay? So then this here would be called the component form of a vector. Okay? Magnitude, we already said, was the length. We can have different names. We can label them with single names or with single letters. We can label them with two letters. So if it's going through the point A and B, okay, you can say vector AB. Where vector A, and we'll get to these here in a minute, I think on the next slide. Yeah, the next slide we'll talk about this. So I'll just wait on the two-letter names on that one. So let's say I have vector P, and it is of the form 5, -2. Okay? So that's the component form of vector P. Okay? Which means that vector P travels horizontally 5 spaces, travels vertically -2 spaces, so vector P would be right there. Ending, so vector P has its tail at the origin and its head at the point 5, -2. Okay. Let's get into some vector operations that we can do to them. Okay. So the first one that we're going to talk about is the head minus the tail rule. So that what that's saying is, if any two vectors with the same length, or any two vectors with the same length and pointing in the same direction, represent the same vector. What we mean by that is, if they have the same component form, they are the same vector. Okay? Because they would have the same horizontal distance and the same vertical distance. Then those would represent the same vector. The head minus the tail rule says that for if I'm looking at vector OP, this would be the tail, this would be the head. So I would take the horizontal first. I would take the horizontal component of P and I would subtract off the horizontal component of O. So that would be 3 minus 0. Then I would take the vertical component of P and I would subtract off the vertical component of O. So that would be 4 minus 0. 3 minus 0 is 3. 4 minus 0 is 4. So the component form of vector OP is 3, 4. Understand so far? So now any vector that has a component form of 3, 4 is an equivalent vector to vector OP. Okay? Which basically means it's the same vector. Okay? So vector RS. So that would be our tail would be at R. S would be the head. So head minus tail rule then is going to say -1 minus -4 would be the horizontal component. Six minus 2 would be the vertical component. -1 minus -4 is like -1 plus 4. That is 3. 6 minus 2 is 4. That gives me RS has a component form of 3, 4. So those two then are equivalent vectors. Questions so far? So we said that vector RS was of the component form 3, 4. You find me the component form of vector PQ and see if that is equivalent to RS, which is equivalent to OP. I also get that it is equivalent to the other two, RS and OP, is PQ, because it has the same component form. Yes? Love it. Okay. Now, I am going to be graphing vectors, okay? But I am graphing it to show you that you don't have to graph it. Does that make sense? Okay? I'm going to show it visually so that you can see what we're doing here. Okay? Okay? So we have vector V. Okay? It has a component form of -2, 5. That means that it's got a horizontal of -2, so left 2, a vertical of 5, so up 5. So vector V goes through or is right there, I should say. Okay? So vector v has a magnitude. So it's got a speed, or it's got a distance, or it's got some kind of a quantity, okay? And it's going in this direction, right? What would the opposite of v then be? Say it up. Going the other way, how long or how fast? The same, right? So it's instead of it going that way, vector v is going to go the same distance, the same speed, etc., in the 180 degree opposite direction, right? Okay? Okay? Well, 180 degrees in the opposite direction would be down this way, right? So instead of going left 2 horizontally, I would go right 2 horizontally. Instead of going up 5 vertically, I would go down 5 to there. And so vector negative v would be right there. Now my question to you is, vector negative v is, oops, I put negative, is 2, negative 5. Without graphing it, how can I get vector negative v of a component form of 2, negative 5 from vector v? Just what? Just multiplying by negative 1? Yeah, exactly. Okay? So in general, if vector v is a comma b, then vector negative v would be negative a comma negative b. Okay? Like you multiplying the component form by negative 1. With me? Okay. Alright. So now let's suppose that we've got vector u as negative 2, 5. Vector v is 3, negative 2. We want to find vector u plus v. Okay? So if I'm finding vector u plus v, what I'm going to be doing is I'm going to start with, for me, when I'm graphing it, I'm going to graph vector u. Okay? Then I'm going to start graphing vector v at u's head. Okay? So I'm going to connect the tail of v to the head of u. And then that result, wherever the head of v is, that's my resultant vector. Okay? I know that that's as clear as mud, so let's go vector u here in blue, negative 2, 5, 2, 4, and 5. So here is vector u. Now I am going to, instead of starting at the origin, okay, now I am going to start at the head of vector u, and I'm going to go 3 horizontally, 1, 2, 3, and negative 2 vertically, which puts me right there. And so that then would be vector v, tail attached to u's head. So vector u plus v would complete that triangle. So vector u plus v has a component form. Horizontally, I went 1. Vertically, I went 3. Okay. Mathematically, without graphing, how can I get 1 and 3 out of vectors u and v? Add the, what am I adding together? So the horizontal parts and the vertical parts, right? So in general, if I've got vector u, let's say that that is a comma b, and I've got vector c, or vector v, we'll call it c comma d, then vector u plus vector v is going to be a plus c, comma, b plus d. You're just going to add the horizontal parts and you're going to add the vertical parts. Okay? Now, if I have something like u minus v, okay, well, u minus v would be the same as u plus negative v, right? Agree with that? Okay. So following our rule that we just had, so then I would say here that negative of vector v would be what? What would the component form of negative v be? Negative 3, positive 2. Okay. So this then would be negative 2 plus negative 3, comma, 5 plus 2. Negative 2 plus negative 3 is negative 5. 5 plus 2 is 7. Okay. Any other way that I could get 5 and 7 without having to do all that extra stuff, like doing the extra negative v? Is there a way? Something with the horizontals and the verticals? Just subtract them, right? Huh. Okay. So if we've got u is a comma b, and v is c comma d, then u minus v is going to be a minus c, b minus d. So if we're adding vectors, We just add the horizontals, add the verticals. If we're subtracting vectors, we subtract. Now order matters in subtraction, so we got to follow that order, right? But we subtract the horizontals, we subtract the verticals. Okay? What if I scalar multiply a vector? By scalar multiplying, I mean, what if I multiply a vector by 3? That's called scalar multiplication. Okay? Well, what that really means is, this is vector v 3 times, right? So this would be vector v plus vector v plus vector v. Okay? So on a graph, it would be 3, 2. So here would be 1. I'm just going to hand draw it in. Here would be 1 vector v. Then I would go here. 3, 2. There's my second vector v. 3, 2. Here's my third vector v. Right? So I've got 3 vector v's there. So all told, vector 3v then would be 9, -6. Is there a quicker non-graphical way to scalar multiply a vector? Just straight up multiply the numbers, right? Okay. Multiply 3 by 3, -2 by 3. Okay. I don't even need to write that one down. That one's... Oh, I see. Here. So if I went... I see. So if we've got vector u... Okay? Don't worry, we're not going to divide. Okay? I shouldn't say that. We would scalar divide, but that's the same as scalar multiply. Okay? So if I want half of vector v, you would just multiply the horizontal component by 1/2 and the vertical component by 1/2. Okay? So, but we're not going to multiply vector times vector or anything like that. Okay? Or divide them. Okay? So here is vector u. Here is vector v. R is 2, t is -3. I want you to now find me vector u plus v in component form, vector u minus v in component form, vector or t times vector u, r times vector v plus t times vector u, and -r times vector u. You find me those 5 now based off of those quantities. So u plus v, I get 1, -2. Yes? Okay. U minus v, I get, so that would be -1 minus 2, and 3 minus -5. That's a bad minus sign. 2 of them, actually. Let's fix both of those. So I get here u minus v is -3, 8. Yes? Okay. T times u times vector u, so that's going to be -3 times vector -1, 3 So that would be the vector then 3, comma, negative 9. R times V, or excuse me, R times V. So that's going to be 2 times 2, comma, negative 5 plus vector TU. Well, T times vector U we just found. That was 3, comma, negative 9. 2 times 2 is 4. 4 plus 3 is 7. 2 times negative 5 is negative 10. Plus negative 9 is negative 19. Negative R times vector U would be negative 2 times the vector negative 1, 3, vector 2, comma, negative 6. Yes on all of those? Questions on any of them? None? Okay. Love it. So let's talk magnitude of a vector. So we've got here vector W. Okay? Vector W has a component form of negative 2, comma 3. That means that vector W would be up in there somewhere, right? Where it would have a component form, or I should say it would have a horizontal part of negative 2 and a vertical part of positive 3. Right? Okay. Now the magnitude of a vector is going to be that vector's length. So how can I find that blue length? Pythagorean theorem, right? I can use Pythagorean theorem. So the magnitude of that vector squared is going to be equal to negative 2 squared plus 3 squared. Right? Okay. Negative 2 squared is 4. 3 squared is 9. 4 plus 9 is 13. So my magnitude squared is 13. So what is my magnitude? Square root of 13. Okay. All right. Now, in general, if I've got vector U and it's got component form A comma B, I can always make that exact right triangle out of it. Okay? And so the magnitude and the symbol for the magnitude is a double absolute value. Okay? So it's a double-walled absolute value means magnitude. So the magnitude of U, no arrow on this U, because it's not a vector, it's a quantity. Okay? Right? So the magnitude of vector U then would be the square root of A squared plus B squared. So the magnitude of W here would be the square root of 13. Okay. the direction angle of theta, or the direction angle of our vector, is going to be found using reference angles. Okay? Because actual theta is right here. That is our direction angle of W. So we write that with a theta and then a subscript W on it, because that's the direction angle for W. Okay? But I can't find that. I need to use theta prime here. I need to use my reference angle from there. So remember that our reference angles, theta prime, is going to be the inverse tangent of y divided by x, and we drop any and all negative signs because we want it to be an acute angle. Okay? So if I have vector u as a comma b, again, then the reference angle, theta prime, is going to be the inverse tangent of b divided by a. And once again, I need to make sure that we drop any and all, oops, not negative one, any and all negative signs. Okay? So my theta prime up here for vector w is going to be the inverse tangent of 3 over 2. Somebody with a calculator, could you calculate for me the inverse tangent of 3 over 2? Good.
56.30.
993.
Yeah.
Okay. But that's my reference angle. Which quadrant is vector W in? It's in quadrant number 2. So because my reference or my vector is in quadrant number 2, that means that actual theta, so the direction of W, is going to be 180 degrees minus my reference angle. First semester stuff. We've done a lot of this already. Okay? So my actual angle, direction angle of W would be 123.690 degrees. Because really it's, bring this down a little bit. Bring that down a little bit. Because really it's, oops. That. Okay. Questions, comments, concerns, clarifications? Sweet.